Chapter 5, Molecules and Compounds. Sugar and salt. We're going to talk about molecules and compounds. So, we'll talk about some familiar compounds. So, table sugar. Here's a model of a table sugar molecule. The chemical name for it is sucrose. It's so much easier when I can see a little bigger. Okay, so sucrose. I'm not going to quiz you on that, but a sucrose molecule has carbon, hydrogen, and oxygen atoms in it. And what's important to understand, the properties of the compound sucrose are very, very different from the properties of the elements that make it up. Okay, sucrose is a solid at room temperature. It tastes sweet. In reasonable quantities, it's not bad for you. Hydrogen is a gas at room temperature. Oxygen is a gas at room temperature. In fact, they're very flammable gases. Carbon is what's in your pencil. Would that be tasty on your cereal? No. It's black and messy. It's not at all like sugar. When elements react to form a compound, their properties change very significantly sometimes. I decided that these slides are out of order, so I'm going to go back to that one. So let's talk about salt. Table salt is a compound formed by sodium and chlorine. Those are elements. Here's an illustration, a picture actually, of spilled salt. Salt looks a lot like sugar, but it doesn't taste like sugar, does it? White crystalline solid. Again, we sprinkle it on our food. A little bit of it is actually good for you. And its properties, though, are very different from those of the elements that compose it. Here are pictures of the elements. Elemental sodium is a soft metal. Okay? Do we normally eat metals? No, they're kind of hard on your teeth, right? They're very hard. Elemental sodium is actually relatively soft, but still not something you'd be wanting to eat. You can cut it with a butter knife. It reacts very vigorously with water, though. There's water in your mouth, right? Would not be a good thing. If you threw a chunk of sodium in the sink, a sink full of water, the sink will explode. It's happened. Not here, but you hear stories. And I feel okay in telling you that because I'm not even positive if we have any sodium in the stockroom, and if we do, it's locked up. Because we're not going to do that. It reacts so vigorously and generates hydrogen gas and so much heat that the hydrogen gas explodes, is what happens. So you don't want to mess around with elemental sodium, and you certainly wouldn't want to eat it. Here's chlorine in its elemental state. It's a gas at room temperature, kind of a yellowish gas, and it's toxic. Okay? But you combine chlorine and sodium together. Separately, they're very bad for you. You combine them together, and they are something that your body actually needs, sodium chloride. You need a certain amount of sodium in your system and a certain amount of chloride ions in your system to stay alive. Now, too much is going to be bad for you, but too much of anything is bad for you. So there's that slide again.